This video is to back up the information given in section 1. It's to more cover the information from the previous video, but in addition to reviewing and summarizing that information, the goal is to actually look at problems from your homework sheet so that maybe you can finish them. Okay, what I wanted to do in this last chapter is look at one other topic that will help you in some of the upcoming classes that you'll see as you go finish up high school. Number one, we've talked about the use of exponents and the properties that exist with those. And we've talked about the use of radicals and how we simplify and perform operations on radicals. What this unit does is it takes and combines the two, okay? And so it says, how can we take radicals and express them using exponents and exponents using radicals, etc. So the basic premise is this. If you have some base b raised to some exponent, okay, you can square root that whole thing, or excuse me, take some nth root of that thing, and it will look like that, okay? Now, according to rational exponent form, then what I'm allowed to do is the exponent on my base and the index n become the two components that make up my rational or fractional exponent. The exponent, it becomes your numerator. Okay, the index becomes your denominator. So this expression here, given in rational exponent form, becomes, well, if I abbreviate here, b to the exponent over n power. No more radical symbol. Okay, so one of the things they want you to do extensively is to convert from one form, radical form, to rational exponent, and vice versa, from rational exponent to radical form. So let me give you a couple of specific examples, and then we'll look at one other topic and then go to the homework. So if I have the fourth root of b to the first power, okay, the numerator is my exponent, the denominator is my index. So this becomes b to the 1/4 power. Okay, written in the same manner. Okay, if I have, let's say we have the fifth root of 4, and you could have a 3 inside or a 3 outside. It really doesn't matter. But with the exponent 3 and the index 5, this would be written as 4 to the 3/5 power. Now, going the other direction, okay, something like 3 to the 2/3 power means I want to take the cube root of 3 squared. Okay. Now, you could, if you wanted to, move that 2 down inside and simplify that, because 3 to the second power is 9. We could use that notation, okay? But since all we're doing is just rewriting in these first examples, that would be your best answer, that first one would be, okay? Now, here's the other thing. When we start to do some simplifying, on the back side of this worksheet, then we need to keep in mind one simple thing, especially when it says simplify without a calculator. If I have the square root of 2 squared, okay, understand that when the index and the exponent are the same, if you put that in rational exponent form, that's 2 over 2, which is 2 to the first, which is just 2. So when the exponent and the index are identical, they cancel each other out. Okay, and that's going to be an important part of simplifying some of the expressions without calculators. Okay, so that's kind of how we're going to start out. So let's take a look at the exercises. Okay, on the top of the page, okay, this first the problem that I have was meant set up to be an example that we could do in class, okay, or together. So that's why it's listed up there as an example. Remember that if you don't see that a base has an exponent, it's automatically 1. So this is 11 to the first power, and I'm going to take the cube root of that. So the index is your denominator. This would be 11 to the 1/3 power. Okay, it says rewrite it in rational exponent notation. It doesn't say simplify. We can't in this case anyway, but all we want to do is leave our answer like that. Look at number 4. Okay, again, same idea. Here's your exponent, here's your index. So this would be 2 raised to the 11/8 power. Okay, excuse my writing. Okay, in 5 through 8, I want to do the same thing but go backwards. Okay, so we're starting with the rational exponent. This would become the 4th root. Okay, the 4 goes out, and then I got 7 to the first power underneath. I don't need that number 1 as an exponent, but there it is as it would be expressed. Okay, same thing with number 8. Okay, 7 is your exponent, 4 is your index, so I would write that as the 4th root of 8 to the 7th power. Okay, so you could also put parentheses around this. You'll see some of the other questions that look like this a little bit. That's the 4th root of 8, and then they put the 7 outside. Same thing. Okay. On 9 through 12, N is your index, A is your number. Okay, so this would be the 7th root of 128. So they're asking you what number would you raise to the 7th power to get 128. Turns out it's the number 2. Okay. On number 10, got to be careful. Well, let's do numbers 11. Got to be careful here when you set these up. Okay, again, this would be the 6th root of -1. Now, one of our discussions from earlier said that if you try to take a negative number and take an even root of it, you can't in the real number system. You can get an imaginary answer, but not a real answer. So since I'm trying to take an even index and a negative radical, okay, then I would say that my answer here is not real. Okay. 10 also has a negative radical, but the index is odd, so you can do number 10. Okay, you can get an answer on number 10. Okay, on 13 through 18, and then there's more of them on the back side, they want you to be able to simplify without using a calculator. And what they've done is they've given you some special numbers, okay, that are perfect powers that you can use to simplify. So for example, let's start with number 15, okay? If I take, I'm going to zoom in here just a little bit so maybe you can see a little bit better. On number 15, okay, you see that you've got a negative outside, which is okay. You've got a sixth root of 64. Okay, now this is where that second rule that I was talking about comes into play. Okay, I want to take a negative of the sixth root. Turns out the number 64 can be broken down so that it's 2 to the sixth power. Now, the sixes, 6 index, 6 power, cancel each other out. So all that you're left with is negative 2. Okay. The number on number 18. Okay, similar problem. 3125 raised to the 2/5 power. Well, if you play with it a little bit, the number 31, 3125, is 5 to the 5th power. Okay, and I'm going to take the 5th root of that, and I'm going to raise that whole thing to the 2nd power. So here's my index. I took the 3,125 and wrote it as 5 to the 5th. The index came out here, the denominator did, and then my exponent out here. The 5's cancel out. The 5th root and the 5th power cancel, so that all that I'm left with is 5 squared. 5 squared is 25. Okay? So, next video we'll cover the back side of this worksheet. So, I'll see you there in a minute.